Now here we'll discuss the shear force and bending moment diagram for simply supported beam with point load at the mid of span. So this is the diagram of simply supported beam. This is the pin or hinge joint and this is the roller joint or roller supported. And at the mid of span, the point load is acting on this simply supported beam where this entire length is L, and from here to here this is A, and from here to here this is B, this length. So all we can say that here L is nothing but A plus B. So I'm giving this is A point and this is B point for the simplicity of analysis. Now to solve this problem, already in the earlier lecture we have discussed the rule and the important points, how to draw the shear force diagram and bending moment diagram when the point load is acting on the beam. So first step that we follow to draw this free body diagram for this simply supported beam. This is the load P here, so RA, here this is RB, and the load is there which is nothing but the entire length is L, and from here to here it's B, and here to here it's A. Just for the convention of it's a right to left. There's no need to write in the examination sheet, it's a rough work only, this right to left. So this is our free body diagram of this simply supported beam having the point load at the mid of this span. Now the next step, this is the first, this second. So equation of equilibrium. So equation of equilibrium, this is the next step, and here summation of, since fx is not there, no need to write, summation of fy, all the vertical forces equal to 0. So here the vertical force is, as per our sign convention, if I move right to left in this simply supported beam, you can move from left to right or right to left, no problem. So just I'm moving here right to left. If I take right to left, downward force consider positive, left to right or right to left, upward force consider negative. This is our sign convention. Right to left, downward force positive, right to left, upward force, this is right to left, upward force negative. So here you can see that this is the upward force RB which I am taking here, negative RB. Only this summation of y means only the vertical forces we have to consider. So it's a negative, P, it's a downward force, P will take positive, and RA negative, equal to 0. Or we can write like this, RA plus RB equal to P. This is our equation of summation of y. Similarly, moment M about anyone, you can take A or B. I'm taking here A is equal to 0. See, moment I'm taking about A, so this moment about A, if I'm taking, this is the A and this is the B, so RB, this is RB, and it rotating this anti-clockwise. So this spin, you can see that this anti-clockwise movement I'm taking as a negative, and clockwise movement I consider this anti-clockwise movement, anti-clockwise taking a negative and clockwise taking positive. Okay, so minus RB anti-clockwise into this distance L, RB into L for the moment, force into perpendicular distance, and then P is a clockwise rotation, so P into A equal to 0. So RB is nothing but PA divided by this. So this is the RB. If I know the RB, equation 1, equation 2, put the equation 2 into 1. Put equation 2, put 2 into 1. Equation 1. So RA will be plus PA equal to P. So RA will be, if we solve, this will be PB by L. So I know the value of RA here, the value of RA, RB. Then this is the second step which I have followed. Third is calculation of the shear force diagram and bending moment diagram. So I can follow here. Calculation of shear force diagram. Now for that, if I take this section, because we know that the shear force calculated up to this section, and this is the RA, which we know that RA value is nothing but this PB by L, this is the RB, and this is nothing but P. So this is the A, this is B. So to know that the shear force diagram, we take the section XX at any point. This is the X equal to 0 and X equal to L here. So if I take this section where only the RB is there, and RB is nothing but the value of RB is PA by L, and here up to section I am taking, this is the section of XX up to X. So this is the shear force V, and so this upward force which I am taking is negative, and this shear force will be here. So this I am taking, shear force will be downward because this is upward. So V minus RB equal to 0. So shear force only the vertical forces will consider. So V is nothing but RB, and so here to here X is there. If I put X equal to 0, so this is the V equal to RB, and V equal to RB from here to here, there is a no load is there, so it will be constant here. Shear force, only the vertical force we calculate. So RB will be at this point B, I am giving this name B, A and B. So RB will be there, and this will be move up to the point here. This is I am giving point C, so up to C it will be constant, and 8P here. If I take the section after that, this is the another section. So RB, see if I consider the another section, this is again X1 or whatever the name I am giving. So this shear force here at P, and after that P. So first I am considering at P, xx, then I'll consider this this will I'll consider after that. So this is the minus RB and downward force plus, so plus P equal to 0. So RB is nothing but PA by L plus P equal to 0. So it will be PA plus PL by L equal to 0, or L is nothing but minus PA plus P. L is nothing but A plus B by L. So here we can consider this minus PA plus PA plus PB divided by L. So this will be cancelled and it will be PB by L. So this will be PB by L. So at P it will be PB by L. So shear force at P, it will be PB by L, and here there is a no load, so it will be moved constantly up to here just before the RA, and at RA it will be 0. How? At this I am taking this at P, this is at P, okay, and at A where RA is there, so this PB is there which is positive in nature, so PB by L, and since it is upward force RA, I am taking negative RA, so PB by L minus RA is nothing but, if you see the RA value is PB by L equal to 0. So at A the shear force will be at A shear force will be 0. It will be 0. So at A shear force will be 0. At P shear force will be PB by L, okay, and at B it will be PA by L. So at B shear force will be RB or PA by L, okay. So based on that we can draw here the shear force diagram. So I draw the shear force diagram. This is the positive shear force, negative shear force, this is the span, okay. So at B we have seen here it will be PA by L. So at B, since it is RB is nothing but the upward force, RB is upward force, so upward force we are taking here the negative when we move from right to left, so it's a negative PA by L. And at P, so this is point C, or at P we can say that, or at C, no problem, both are same, C point or P point. So load will be constant here, so constant if there is a no load in this span, so it will be goes horizontal constant line, okay. But at P or at C, you can see that at P or at C, PB by L. So here that is because it's a downward force, so we will take the positive diagram, so it will go here to here, this is PA by L, and it will go PB by L, positive side. So this is the point where the shear force is 0, so V equal to 0 here, and this is the PB by L. So because at P it is value PB by L which is in the positive, because downward force is there of P, so it will go up in the positive side. And just before this V I am writing here, just before A, it's the same PB by L, it's a constant line, no load is there, and at A it's a 0, again it reverses back, at A it's a 0. So this is the negative and this is the positive. So this is the diagram, shear force diagram, for this particular the point load at the mid of this simply supported beam. Now again I am just repeating, because this is the shear force diagram for this point load which is acting at the mid of the span of this simply supported beam. So we calculated first the free body diagram, and then the equation of equilibrium we have made. So the equation of equilibrium, we calculated the RA value, RB value. Then what you did to calculate the shear force diagram, you have to follow these steps, that at B what is the loading condition is there, what is the value at B. So here we have calculated at B the shear force will be RB, that is PA by L. So here at particular B point, here it's PA by L, vertical line will be there, okay, because load is there, point load is there, so it's a vertical line, but downward side, because that RB is a upward force which we are taking negative, so it will go negative side. Then no load condition is there, horizontal it will go. Then suddenly it changes, because at P point or C point the value is PB by L, which is the positive, so it will go positive side. And then up to just before A the value is same, no load is there, so PB will be constant horizontal. And at A it's a 0, because already we have calculated at a shear force will be 0. So PB by L minus RA we have calculated, so PB by L minus PB by L equal to 0, because PB by L is up to P, so PB by L, and this PB by L is going here constant. This is the downward, so it will be positive, and here it is upward, this will be negative, so PB by L minus RA. So here its value is 0 at A. So this is the shear force diagram for this simply supported beam having the point load at a center. Now we can draw this. Now next we'll see the bending moment diagram for this calculation, bending moment diagram calculation for this simply supported beam. This is RB, this is RA, and the value of RB is PA by L, and this is PB by L. This is the span P, and this is A, and this is B. Total length is L. If I see this thing now, the bending moment diagram step at B. If you see at B, here there is a no force, x equal to 0 here and x equal to L here. So at B the bending moment will be 0. So how it will be 0? For that, if you cut the any section x, and this is nothing but PA by L up to section x where x equal to 0. So if you calculate this PA by L into x at B, x equal to 0, so this will be PA by L into 0, that will be 0, because this P and the reaction will bend this beam like this. So appearance will be looks like this bending. So this is called the sagging, and sagging we are taking positive. This we are taking positive, and from right to left, if I move, this type of upward movement will take the positive if you move right to left. So here at B the value will be 0. 8P step 2, 8P what will be there? So if you see 8P, this is nothing but RB into x. So x equal to B, if I take at this distance up to this is B, this length is completely, this length is B here to here. So x equal to 0 at B, it's a 0. X equal to 0 at B, it's a 0, and x equal to B, if I take x equal to B, so at P it will be RB into x equal to B. So positive we are taking because we are moving right side, and upward force, this force will be taking positive. So RB value is nothing but P A by L into B is nothing but P A B by L. So at P this will be there, and at A, if you take at A, if I take section from up to complete length L, x equal to L up to RA. So here this is the PA by L and this is the P, where this is the distance B and this distance is A. So if I move this, it's taking positive, so PA by L into up to this L distance A plus B, so positive you are taking, minus this P into A distance up to here, P up to here at point A we are taking, so this is A equal to 0. So if you see P by L cancel, PA minus PA equal to 0. So at A bending moment will be 0. So how to draw this bending moment diagram? So we know that the shear force diagram which we have already drawn, so positive shear force, negative shear force. So already we have drawn, this was earlier we have drawn, this was the negative, positive shear force equal to 0, and it was so point B at point A. So already we have drawn these things, and this value was PB by L. Similarly, if I draw this bending moment diagram, this just I extend this point B. So at point A bending moment was 0, at point B bending moment was 0, and at point P, this is the point P where bending moment was PAB by L. So here it's increasing inclined. Already we have discussed in the earlier lecture that if the point load is there, then the bending moment diagram will be inclined. So I have drawn inclined, this line inclined, and this is PAB value. So this is PAB value and it is inclined, this bending moment diagram for this particular point load. So this is the positive bending moment diagram. So this is all about the shear force and bending moment diagram for the simply supported beam having the point load at the center.